In the name of God, my name is Mehdi Kordnavasi. This is a fourth movie of the Software Architecture and Design, Chapter 4, a technique for architecture and design. We are starting in the quality attributes. Quality attributes are the overall features of your architecture that affect runtime behavior, system design, and user experience. The extent to which the application processes a desired combination of quality attributes such as usability, performance, reliability, and security indicate the success of the design and the overall quality of the software application. When designing applications to meet any of these qualities, it is necessary to consider the impact on other requirements. You must analyze the trade-off between multiple quality attributes. Quality attributes represent areas of concern that have the potential for application-wide impact across layers and tiers. Some attributes are related to the overall system design, while others are specific to runtime, design time, or user-centric issues. Use the following list to help you organize your thinking about the quality attributes and understand which scenarios they are most likely to affect. The first one is system qualities. The overall qualities of the system when considered as a whole, such as supportability and testability. The next one is the runtime qualities. The qualities of the system directly expressed at runtime, such as availability, interoperability, manageability, performance, reliability, scalability, and security. The next one is design qualities. The qualities reflecting the design of the system, such as conceptual integrity, flexibility, maintainability, and reusability. And the last one is the user qualities, the usability of the system. Let's see a short movie to see how the test of the quality of the software is important in the real world.
Hi, my name is Sanjay, and in this video I'm going to talk about testing as a career choice. In 1946, Grace Hopper, a computer engineer at Harvard University, discovered a moth trapped in one of the computers. The moth was taped on the computer's logbook with the words, "First actual case of a bug being found." It is more than 67 years since that incident, but bugs show no sign of going extinct. In 2011, for example, Toyota recorded more than 150,000 of its Prius hybrid cars. The root cause was a software problem. The Prius had a bug. Software failures have also resulted in deaths. In a series of accidents in Panama City, at least 8 patients died due to overdoses by radiation therapy planning software. Bugs lead to a demand for professionals who are able to detect them, the demand for software testers. Software testing is the process of determining if a software product will be acceptable. A software bug or defect causes software to produce incorrect or unexpected results. These bugs can arise from mistakes made while designing the computer program or writing it. Some bugs may have minor effects on the output and lie undetected for a long time. Others may cause the program to crash. Others have more extreme outcomes as discussed earlier. Software testing is implemented during different periods in the software development process. Furthermore, though testing is primarily done by testers, it is common for developers or programmers to also test code. A significant task of a tester is to generate and execute test cases. Let's take a simple example. You have written a program that finds the result of dividing two numbers. Thus, your possible input range would include all numbers. But how does the program behave if you try dividing two alphabets? What happens if you divide a number by 0? Testers thus have an attention for detail. They test code written by programmers based on requirements from business analysts. Good communication skills are thus a key attribute in such scenarios. Test cases are read by the testing team, analysts, developers, and even customers. Thus, good written communication skills are a big plus. In general, a technical background is not a prerequisite for becoming a tester. However, there is an aspect of testing called automation testing. The instructions given to such automation tools require some programming exposure. Employees often expect candidates to have at least a bachelor's degree in computer science, engineering, or a related field. In addition, many employers prefer to hire candidates who have attained certification. Now let us look at some of the joys of this role. With testing, you have a bigger picture of the system. You interact with the business to see how a customer will use the software. You also interact with programmers when you run test cases and share your results. The training and documentation teams too may get in touch with you to understand different aspects of the software. As a customer, there's a feeling of satisfaction when a product behaves as you expect it should. A tester thus is like a lifeguard, anticipating and stopping problems before they get to a customer. Many testers find this aspect of their job very satisfying. Now let us look at the other side of the coin. Testing can at times seem repetitive. For example, when a new software version is released, existing functionality may still need to be tested. This aspect is called regression testing. Then you can deal with developers who are quite possessive about their work. When you spot problems, you have to deal with defensive developers. This can be stressful. Lastly, in some companies, testing is not given the importance it deserves. This could make you feel undervalued as a tester. Now let us talk about the prospects of being a tester. One would generally enter the industry as a junior tester. On an average, within 5 years, you could be promoted to a senior tester. A senior tester works with more complicated test scenarios and also mentors junior testers. On an average, within another 2 years, you could move into the role of a test lead or test manager. In a nutshell, this role would involve creating test plans and strategies. Some companies choose to hire test consultants, so consultancy in this space is an opportunity too. Last but not least, diversification into other roles is another common practice. Moving into other roles such as business analysis, project management, and business consultancy are pretty common in the industry. So this brings us to the end of the session. The objective was to give you a flavor of the role.
Okay, let's have a detailed overview of all quality attributes in this movie, about 5 minutes. Let's see together.
Quality attribute categories on this slide typically are important and visible to users, so they're indicators of external product quality. Availability has to do with whether the system services are available when and where users need to use them. Availability is not black and white. Of course, everyone wants a system to be available at any time, but in reality, sometimes it's acceptable to have certain system functions that are not available at particular times or in certain locations. Installability describes how easy it is for a user to install the product correctly. Installability also encompasses uninstalling a product, reinstalling it on top of itself, installing updates or new versions on top of an older version, adding additional components after a partial earlier installation, aborting an installation partway through, and recovering from an incomplete or unsuccessful installation attempt. Installability typically is the first experience the user has with the product. There's a little heuristic I use. If I encounter problems during the initial software installation, I don't have much confidence in the overall quality of the product, and it makes me somewhat nervous to use it. Integrity addresses how well the system protects against access by unauthorized users, user privilege levels, protection from virus infection or Trojans, and protection against data loss. Security is one important aspect of integrity, but security doesn't normally encompass data integrity, so integrity is broader in scope than just security. Interoperability has to do with how easily your system can interchange data or services with other applications. We've already discussed performance as measuring how quickly the system responds or executes a given task. Sometimes performance is treated as a separate type of non-functional requirements, other times it's included as a quality attribute. It really doesn't matter very much, so long as you address it. Reliable systems can be used for a long time, maybe forever, before a user experiences some kind of a failure. But if the user does experience a failure, how easily and quickly can he recover from that failure and continue working? Robustness describes how well the system responds to unexpected operating conditions. Fragile systems do not handle invalid entries very well, but robust systems do. Sometimes when users are describing a system as handling errors gracefully, they're thinking in terms of the robustness attribute. Safety is an issue of how well the system protects people against injury or death, or whether the system avoids causing damage if it encounters a problem. People are rarely injured by exploding spreadsheets, but real-time systems that include hardware and software components have very real safety concerns. Usability is a very large attribute domain that encompasses both ease of learning and ease of use. The arena of usability and human factors in the human-computer interface has been well studied, and there's a very large volume of literature in this area. Usability goes far beyond the colloquial term of user-friendly. So these quality attributes are primarily important to the user's experience with the product, the external quality of the product. Here's another set of quality characteristics that relate more to the internal quality of the product. So these are particularly important to developers and support staff. Indirectly, of course, these attributes have an impact on the user's ability to get value from the system in a happy kind of way. Efficiency addresses how well the system utilizes computer resources such as processor capacity, disk space or other storage media, memory, network or other communications bandwidth, and so forth. Efficiency directly relates to the user's perception of performance. By flexibility here, we are not referring to end-user flexibility in their tasks, but rather how easy it is to update and modify the system to add new functionality. Similarly, maintainability has to do with how easy it is for developers or support staff to make changes in the software or to correct errors that are discovered. Maintainability is influenced by how easy it is for someone besides the original author to understand the software code and other artifacts. Portability, of course, addresses how easily developers can make the software run on platforms or operating systems other than that for which it was originally intended. Reusable software makes it easy to take components from the original application and use them in some other application. Scalability is a matter of whether we can add additional capacity to grow with the user base. How easy is it to support more concurrent users without compromising the system's performance? Can you readily plug in more output devices or input sensors than it was originally intended to control or monitor? Can you move the software onto multiple servers or databases to meet the needs of a geographically distributed and growing user population? Supportability broadly addresses the ability to effectively support the application after it is in use. Is it easy to make changes, install patches, assist users, and so forth? Finally, testability rates how easily we can determine whether the software was implemented correctly and is operating as expected. As you can see, there are many dimensions to software quality. I've seen lists of nearly 50 quality attributes. No one's going to worry about 50 attributes on a typical software application, but it's important that you be able to specify quality expectations in several dimensions that are important to the success of your project.
Okay, thank you for watching this movie. And for the next movie, we continuing about the cross-cutting concerns such as authentication, authorization, caching, security, configuration management, validation, and something like that. Thank you very much.